Okay, guys. Again, today morning I recorded this session, but apparently I didn't unmute the audio, so you couldn't hear any of my voice. So I am re-recording this session again. So I'm going to go through the entire PowerPoint presentation again, but this time I already did all the work and everything when I did this recording first time. So you might not see all the steps whereas I was writing it down, but you will see all the work I finished already. So I apologize for that. I would have did my work correctly the first time. I accidentally unmuted it, so you couldn't hear any of my voice in my previous recording. So let us start again. Let us start share the application, and this is the one which I did before. I'm going to start again. Okay, guys. So hope you all can hear my voice as well as I think you can see the PowerPoint presentation as well. This time I'm going to do section 2.9, permutations and combinations with repetition. This is not 2.8, this is 2.9. So that is a typo there. You already know what is a permutation and what is a combination. So you can see that this is the first time I did the work, but I'll just go through this again. So we know what is a permutation means. It is denoted by P of n comma r. That means there are total n objects you have with you and you are selecting r out of the n. And when it comes to permutations, you are thinking these r n objects are different from each other and you cannot pick the same thing again and again, and the order in which you pick things is important. Then you call that as P of n r, and the formula is given by here. Please remember, in this case your r is all the time less than or equal to n. That means, for example, P of 5 3 means you're selecting 3 things out of 5 things. That makes sense because you cannot pick same thing over and over. But if say P of 3 5, it doesn't make any sense. So it's not going to make any sense. People call that as 0, or you can simply say do not make any sense, because you cannot pick 5 items out of 3, because you cannot pick the same thing over and over again. This is going to completely change if you can pick the same object more than once. That means if I can pick the same thing over and over again, then even P of 3 comma 5 also makes sense, because I can pick the same item as many times as I want. This is called sampling with replacement or repetition, whatever you will call it. I will explain with the help of an example. You see that this is all I had done already the first time, so I don't want to write it again. In National Hockey League, there are 3 different results are possible for each game. NHL means National Hockey League. In each game, a team can either win or lose in overtime. Okay, so there are 3 results. In a 5-game schedule, how many different seasons are possible? That means each team is going to play 5 different games. I'm asking how many seasons are possible. Here I'll explain what a season means. Look into this. Here it represents first game is winning, second game is losing, third and fourth are winning, fifth game is losing in overtime. This is one season. When it comes to the second one, the first game they lost, second one, third one, fourth one, and fifth is losing in overtime. These two are 2 different seasons. But if you observe overall record, here also you'll have 3 games winning, 1 game losing, and 1 in overtime. Here also 3 games winning, 1 losing, 1 overtime. But these two are considered 2 different seasons, because in this season they started on a winning note, here they started on a losing note. So these are 2 different seasons. So how many of these different kinds are possible? Here you can think of this as simply a product rule, because there are 5 games each team is playing. Each game there are 3 possible results. So if you use the product rule, you're multiplying 3 5 times 3 power 5. This is simply a product rule. Another way you can think is, I am selecting there is a 3 set: winning, losing, or losing in overtime. So this as a set consists of 3 elements. I am picking members from these 5 different times. That is denoted by P power R. This is order in which these things happening are important, because this is a different order than this. This is a different season. So this is a permutation, and I can select same W more than once. So this is with repetition. and the set consists of 3 members, and I'm picking 5 members out of 3. This is represented by p power r 3 comma 5. So that is simply I'm multiplying 3 5 times, 3 power 5. So if I generalize this, that is what's going to happen here. P power r m comma r means you have a set consists of m elements 1 2 up to m, and I'm selecting r things out of these m, and but I can select the same thing over and over again. That means repetition is allowed. That means there are r spots I need to fill. Each spot there are m choices to fill the first spot. Since the repetition is allowed, there are m choices to fill the second spot. So m I'm multiplying r times, so this is m power r. So a permutation with a repetition is simply a product rule. Here p power r 3 comma 5 is also possible because I can pick the same thing over and over again. So the permutation, a regular permutation you have seen in the previous recording, and a permutation with replacement is simply a product rule. But the same logic things will change when it comes to combinations. So let us go to one more example. Suppose if a replacement is allowed, there is list all the 2 permutations of a 3 set. That means a set consists of 3 members, a comma b comma c, and you are selecting 2 items out of 3 things, and I can pick the same thing again and again. So if you simply use the product rule, then I'm picking 2 elements, and for each spot I can select either a, b or c. There are 3 ways I can fill the first spot. There are 3 ways I can fill the second spot. That is 3 power 2. That is going to be simply 9. If I want to list all of them, that is AA, AB, AC. These are all the different ways I can pick, A being the first one and second one can be A, B or C. Similarly, now I can start with B. So please remember, this is a permutation. Order in which I pick things are important. So AB is different from BA. And similarly, BB, I can pick the same thing twice, BC. Similarly, CA is different from AC, and CB is different from BC and CC. There are total 9 things. Most of the times, I will not be asking about listing all of them because this is a painful process, but I will just ask the final answer. The answer is 9. How many ways you can do this? So when it comes to permutations with repetition, this is simply a product rule. That's not bad at all. But if you do the combinations the same thing, then that is going to be changing a little bit. Okay guys, so let us go to the combinations. Again, you can see that everything I had worked out the first time I had done the recording, but I don't want to write it again. I hope you can understand. And this is combinations. Just to review what we had seen, again you are selecting R objects out of n. Again the entire list is same, the n object should be different. Repetition, I cannot pick the same thing over and over, but when it comes to this, order in which I pick things is not important. This is given by the formula C of n comma r. Here also your r is always smaller than n, so n has to be bigger than or equal to r. That means C of 5 3 makes sense. C of 3 5 you can simply means you can say that as 0, because I cannot pick 5 items out of 3 items because I'm not picking more than once. But if I allow things to be replaced, that means if I can pick the same item more than once, then this makes sense as well. Let us explain with the help of an example. Let us pick the same example you had seen before. If a replacement is allowed, then list all 2 combinations of a 3 set. That means I have a set consists of 3 members. Now I want to pick 2 members out of these 3, and I am saying with replacement. But only difference compared to the previous example to this is order here is not important. So look at the previous, see we listed in the previous page there are 9 different ways I can do this. You see these 9? Let us take all these 9 and see how many of them are immaterial here. See AA, that makes sense. AB is fine. AC is makes sense. BB is fine. But you observe BA is exactly same as AB, because order in this case I don't care. So once I pick A and B, that means I picked B and A as well. So this it doesn't matter. BC is good. CA and AC are same, so I don't need to pick that twice. CB and BC are same, so the only thing is CC. So there are total 6 possible choices I have. That means this is denoted by C power R. R represents repetition. C represents combination. I'm picking two elements out of a three set. This is represented by C power R 3 comma 2, and I got the answer as 6 just by brute counting. So here the formula, which is on the next page, theorem 2.3, the formula is C power R m comma R is given by C of m plus R minus 1 comma R. Again, the proof is not really bad, but I don't want to spend time in going through the step by step. So please go to page 50 and read the proof. And this is not very difficult for you to understand. So I strongly recommend you to go through the proof. But if you compare the previous example, we know the answer we got as 6. So C power R 3 comma 2, if I use this formula, that is 3 plus 2 minus 1, that is 4 comma 2, C of 4 2, you can leave your answer like this. But if you decided to use the formula, that is n factorial over r factorial times r n minus r factorial. So this is 4 times 3 times 1. Again, and if you cancel all of them, then the answer is 6. So you got the same thing. So now let us look at one example. So here it boils down to for you to figuring out, like the previous one, is it a permutation or combination? In National Hockey League, there are three different results possible for each game. A team can either win, lose, or lose in overtime. In a 5-game schedule, how many different final records are possible? Please remember, this final records is different from each season. For example, this is example 1. If you go back and you can see that this is one season for the team: win, win, lose, lose, and lose in overtime. This is another season. This is first game they lost, second game they won, lose, win, and lose in overtime. But if you observe, there are 2 wins and 2 losses, one lost in overtime in the first season. In the second one, there are 2 losses, 2 wins, and one lost in overtime for the second season. But when it comes to a record, I only care about how many wins the team has, how many lost it has, how many lost in overtime. So when it comes to final record, these two are the same thing. There is absolutely no difference. So this becomes a combination because I don't care about the order. That is the reason I'm saying C power R. I have a 3 set: winning, losing, or losing in overtime. And I am picking 5 elements out of these 3 sets. That is possible because I can pick W more than once, L more than once, O more than once. So this is C power R. I'm picking 5 elements out of a 3 set, 3 comma 5. And the formula simply says is m plus r minus 1 comma r. So you need to add these two and subtract 1 comma 5. This is C75. And again, I don't want to list all of them, but if you do the math, n factorial over r factorial times n minus r factorial. If you simplify, you get 21. But you can leave your answer as C of 7 comma 5 in the exam or in the quiz. Listing all these 21 different records are a pain in the neck, so I'm not really keen on that. Again, as I mentioned, I am more interested in for you to figure out is a permutation or a combination. Let us do 2 more examples. Let us do 2 more examples. What happened? It got stuck or something? Yep, I got it. Yeah, I should have previous recording. I discussed and I worked at the same time, so it gives you a little bit more time. In how many ways we can choose 8 desserts if 4 different varieties are available? Assume there are 4 different varieties of desserts: A, B, C, and D. Now imagine you have 8 guests at your house, and how many different ways they can pick out of these 4 things. For example, guest 1 can have A, B, A, B, A, D, D. That means there are guests who picked dessert A 4 times, 4 people, and dessert B 2 and dessert D 2. And this is another way of doing this. But how many ways you can do this? As a person, for you, you really don't care how whether the first person picked A or first person picked dessert B variety. All you really interested in is how many A's are getting consumed, how many B's are getting consumed, how many C's and D's. So that means this is a 4 set. and I want to pick 8 items out of this 4 set. And since repetition is allowed, this is possible, and I don't care about the order, so this is a combination. So according to the formula, 4 plus 8 minus 1 comma 8, this is C of 11 comma 8. So again, here it all boils down to figuring out whether the order is important or not. Let us look at example 6. Suppose a password of length 8. Suppose assume your computer password or internet password. It should have a password of length 8, and they should consist of 3 letters ABC and 2 digits 0 and 1. How many different passwords you can have? For example, this is one password AAABBC01, and this is another password 01CBBAAA. If you compare both of them, it has 3 A's, 2 B's, and 1 C, and 1 0 and 1 1. Even it has 3 A's, 2 B's, 1 C, 1 1, and 1 0. But these two are different passwords. So this is order in which you arrange these letters are important because it gives you different passwords. So this is a permutation. So you have 8 spots to fill, and each spot I have 5 different choices. So this is P power R is a 5 set. I am picking 8 members out of the 5 set. If you simply product rule, I'm multiplying 5 8 times, that is 5 power 8. Again, hope this time you all can hear my voice as well. Again, there is one advantage of doing this. This video is going to be much shorter than the previous one because when I started working and explaining at the same time, it took like 16-17 minutes. This is going to be shorter, but there is a disadvantage. It will not give much time. So again, I apologize. Hopefully this time everything is recorded okay. So thank you so much, guys. I'm going to stop sharing this now. Now I'm going to close this. Now I'm going to stop the recording.